Interoperability is an award-winning IoT software company that enables organizations to quickly and efficiently manage their IoT devices. We do this through interoperability and through lightweight M2M. Before we get started, a few housekeeping items. The first note is that the webinar will be recorded. I will also send slides and a recording of the webinar after it has ended. And you might notice that everyone is muted, but that does not mean that we don't want your questions. So we encourage you to send them through the Q&A, through the chat for the Q&A session afterwards. For today's agenda, we will discuss IoT interoperability best practices. We will discuss Orange Live Objects, the Orange IoT ecosystem, and its value. We will discuss how to accelerate access to Orange's catalog. And as I mentioned previously, we'll have the interactive Q&A session, so please send your questions whenever you have them. For today's speakers, we have Elsa, who is a product manager at Adeunis, and she will share a lot of the stories surrounding how Adeunis worked with Interoperability and Orange. And we have Mark from Orange, who is the IoT solution product manager. And we have myself, who is the marketing director at Interoperability.
Okay, so hello everyone. So I'm Elsa Bernard-Moulin, a product marketing manager at Adeunis. And I'm happy to be here today to represent Adeunis and to share with you our experience in integrating the lightweight M2M protocol into our lineup of cellular sensors.
Elsa,
Yes.
we lost
Oh,
your
sorry.
sharing, I guess.
Sorry about that. Is it okay?
It's okay. I think we can
okay.
work with that.
You might want to switch screens.
Okay, so Adeunis is a French SME with over 2 decades of experience, and we focus today on the design of connected sensors via wireless protocols like LoRa, Sigfox, and now cellular IoT protocols. So our R&D team is based in Grenoble and comprises firmware, hardware, radio, and software engineers designing all our products. In addition to this technological expertise, we also have a significant industrial know-how, having sold over 5 million products globally since the foundation of the company. In parallel, we also offer our customers a suite of services, including applications for configuring our sensors, for decoding their data. We also provide network coverage studies and IoT training, for example. Our objective is to support our customers and to facilitate the deployment of their digitalization project through IoT. So our sensor primarily target operators, maintenance professionals, and all those in energy or facility management. These sensors seamlessly fit into various buildings, from residential spaces to offices, commercial setups, or healthcare facilities, for example. And we offer around 30 sensor models addressing the need to collect diverse building-related data to tackle challenges like reducing the energy costs, enhancing occupant comfort, and optimizing equipment maintenance process. So here, you have a typical Adeunis customer profile. This customer deploys over 1,000 sensors across European buildings. They need to manage those sensors for at least 5 years with remote data retrieval and processing. For such customer, managing heterogeneous sensor fleet remotely is crucial to monitor the state of their assets, to configure applicable parameters as needed, or to update sensor software, for example. So they do require a sensor management protocol that simplifies and automates these tasks. For us, lightweight M2M is the go-to protocol for such large-scale IoT deployments and long-term fleet management. That's why our cellular sensor range is compatible with lightweight M2M, and we do strongly encourage its use among our customers. This protocol has been developed by the Open Mobile Alliance, and lightweight M2M is specifically designed for operational management, data processing, and the lifecycle management of any IoT devices. So today, I won't dive into the details of lightweight M2M. Mark from Orange will handle that. Instead, I rather share some practical insights on 4 key advantages of lightweight M2M in the context of battery-powered connected devices dedicated to smart building applications. So the first advantage of lightweight M2M is the remote management of IoT devices. As I mentioned previously, our customers deploy numerous sensors, actuators, and connected devices, and they all need a centralized monitoring and control, even if these devices are distributed across different sites and without the need for physical intervention. So lightweight M2M provides a robust mechanism for the remote discovery, the configuration, the control, and updating of these devices, all from a central server. And this greatly facilitates the system maintenance and management and allows our clients to save time and reduce their operational costs. So for example, once an Adeunis sensor is installed, a customer can view its current configuration and easily modify parameters such as the sampling interval or transmission interval from the lightweight M2M server, and with just one click. This flexibility extends to easily setting threshold rules, for example, triggering data transmission, for instance, if the measured CO2 level exceeds a certain threshold. And this flexibility allows our customers to maximize the operational efficiency and to optimize the lifespan of the sensors. Integrating the lightweight M2M protocol into our sensors also enables us to provide customers with the latest firmware updates, even after deploying a significant number of sensors in the field. So firmware over the air, what we call the FOTA, is a standardized operation in the lightweight M2M protocol, and it takes only 5 to 15 minutes to download the update file, depending on the network used for the communication. So unlike LoRaWAN or Sigfox protocols, lightweight M2M does not require codecs or connectors to process the data sent by devices. Instead, lightweight M2M offers a standardized data model, what we call the standard object in the lightweight M2M jargon, enabling a seamless communication between devices from different manufacturers. For our customers, this interoperability significantly simplifies the system integration, the data collection, and analysis from multiple sources, and all this facilitates a centralized management of device. Our sensor expose standard profiles for data such as the temperature, the humidity, CO2 levels, the pulse counting, for example, as well as for the network and product-related parameters. So in terms of data modeling, the lightweight M2M protocol is very flexible, allowing sensor manufacturers to combine standard objects with proprietary objects to transmit data related to specific functions of their products, or to offer complementary operating modes. And to be honest, as a manufacturer, it's not always easy to anticipate what the customers will need. So at Adeunis, we have developed a custom object for each of our products. And for example, this custom object allows our customers to manage alarms with hysteresis, for example. So as you've understood, our sensors are battery powered. So for us, consumption, both in standby and during the data transmissions, is a critical point to ensure our products operate for several years without maintenance. So the lightweight protocol theoretically is well suited for these constraints. And that's one of the reasons why we have decided to integrate it into a range of cellular sensors. I'm going to present two concrete examples, and you will quickly understand why we are convinced that we've made the right integration choice with LwM2M. So here, you have an estimate of the autonomy of our cellular sensor measuring temperature and ambient humidity inside the building. In a context of sampling and transmission every 10 minutes, we observe that our product's autonomy is 2.5 times better with the LwM2M protocol compared to the MQTT protocol. And if I share here a use case where the sensor sends its data once per hour, we again see a factor of 2 to 3 when comparing the energy efficiency of these two protocols. So meaning that for LTE-M network with MQTT, we can expect device autonomy between 5 to 15 years, and with LwM2M, it's 15 years and more than 20 years when you have a good network. So why have we observed such differences in consumption? So in LwM2M, with space transmission of at least 5 minutes, the connection ID will help to maintain the security context, what we call the DTLS, and therefore, with each transmission, our sensor transmits only the data monitored and not the security elements. And this results in less data transmitted in each exchange with the server. So shorter modem sessions, and ultimately this optimizes the sensor's consumption. On the other end, with MQTT, our sensor sends 90% of security-related data for each transmission, because a complete security session needs to be recreated with every data transmission. Another reason for this consumption gap between the two protocols is that LwM2M uses the UDP transport protocol, while MQTT uses the TCP transport protocol. And since TCP is more sensitive to latency in exchanges, we observe more potential packet losses in case of a poor network or an NB-IoT usage. And this leads to retransmissions and ultimately more consumption. So LwM2M's impact on data transmission not only boosts sensor autonomy, but also allows customers to potentially reduce their telecom subscription costs. For a use case where our sensor records temperature and humidity data every 10 minutes and transmits them once per hour, the monthly data consumption is 430 kilobytes with the LwM2M-based communication, compared to 5,250 kilobytes if the sensor uses the MQTT protocol. So it's 10 times less data with LwM2M compared to MQTT protocol. At Adeunis, our R&D journey took 2 years to develop our new hardware and software platform, integrating the LwM2M protocol, and our development teams benefited all along from the support and responsiveness of technical teams, both from IoT Europe for the stack and for Orange for the IoT infrastructure. So I'm very glad to be here today with both IoT Europe and Orange to share with us, with you, what we have now to offer in terms of cellular IoT sensors, including integrating the LwM2M protocol. And currently, we do have 3 products in our catalog integrating the IoT Europe stack. The Pulse, enabling the remote reading of data from Pulse output meters, whether for water, electricity, or energy meters. The Comfort device, dedicated to temperature and humidity monitoring in a building. And the Comfort Serenity, which in addition to monitoring temperature and humidity, Also allows monitoring indoor air quality by measuring CO2 levels and volatile organic compounds. So more cellular sensor projects are underway, including a network tester and a dry contact sensor. And of course, we are open to collaborating on custom IoT projects based on our hardware and software platform. So feel free to reach out for collaborations. Okay, so I'm done now with my part. I think.
So hi everyone, I am Marc Delin. I'm from Orange Innovation, working on product marketing on the LiveObject platform. I will be talking a little bit later, and I will share the reasons why we chose LwM2M protocol at Orange for device management over MQTT that we use to support. We still provide MQTT capabilities on our platform, but we now prefer way more LwM2M. Just a quick recap about the IoT scope at Orange, from IoT networks to application server. We operate LoRa network in several countries nationwide. We also operate cellular network, of course. We have our own in-house IoT platform for device and data management, and we are able to support our customer up to application server / vertical solutions with Orange Business worldwide. Today I will focus more specifically on the LiveObject platform, so our IoT platform, to explain why we chose and why we prefer LwM2M from the platform perspective. So quick word about LiveObject, which is a multi-connectivity platform. We can manage on the same platform LoRa devices and IP devices, making it easy for our customer to consolidate their fleet, to filter data, transform data, and ultimately make those data available to the customer, either on public cloud with specific connectors to publish the data on this cloud, or on the customer infrastructure if the customer is having its own systems. LiveObject is API first, so every functionality in LiveObject is available through APIs. Of course, we do have a web interface, and we also have a mobile app on Android for a field technician in order to provision and configure the sensors remotely. So basically, regarding the connectivity, I spoke of LoRaWAN and 0G connectivity. We are able, through connectors, to also gather a Sigfox fleet. Of course, we can also gather data from satellite IoT, and in the IP world, so we are talking about Wi-Fi, Ethernet, wired connectivity, plus of course cellular connectivity. It's mostly MQTT, which is the most popular protocol, but we'll see that it has also a few caveats that on which LwM2M, to our opinion, is much better. For today, of course, we will more focus on cellular IoT with LTE-M and NB-IoT okay, so quick return on experience on our MQTT on the project that we could witness using MQTT. Most of the time, the project is about collecting data on the field. So telemetry is always well implemented. However, we see much less integration regarding remote configuration or remote control. Sometimes there is no firmware update capability, embedded in the devices. Sometimes the connection is not secured still today. It's still over MQTT custom implementation because MQTT is only a way to transport messages, but the content of the messages is completely open. So it means that every device has its own language and every platform has its own language. So we need the both parties to be able to talk together. So either you have to modify or customize the device, either you have to decode or put some applicative gateway in front of the platform in order to for the communication working well back and forth. And finally, over MQTT, well, for MQTT, we also have a resilience issue because MQTT is based on TCP, which relies on, which needs low latency. And it's not always the case if you have bad coverage or if you are using NB-IoT, because NB-IoT has latency much higher than LTE-M and other cellular networks. So you will probably have to reestablish the communication and consume more data because you have to retransmit the data you were transmitting when the connection was interrupted. So it leads to several limitations, some severe. So we have seen that we have limited or purely no remote management because if you don't implement firmware update, you can't optimize your device over the time. Should it be for power consumption or renewing security items, keys or certificates. Because of this lack of security renewal plus potentially unsecured connection, you have a risk of data compromise or takeover of the device. Because of custom implementation from MQTT, it leads to complex integration. And if you want to add more device to your fleet, then you have to do more integration because every device is different. Every type of device, of course, is different. Plus reliability and durability issues under bad coverage or NB-IoT usage. And that's where LwM2M is, from our point of view, way more efficient. LwM2M is a standard standardized by OMA. It's a standard, but the standards provide also interoperability, meaning that every device is able to talk to LwM2M device is able to talk to every LwM2M platform, basically. So it's very easy to compose your system with devices and platforms, switch your bricks if you want to use another platform, another device, without having to redo the implementation or the integration between the device and the platform. It's simple because we have a standardized data structure, which is not limiting because you can expand this structure with your own data or features if what you need to use is not in the predefined data structure. We'll see that later. It's secured. It relies on very common and very well-known security protocol, and it's lightweight. And there, Mackenzie will talk about the lightweight part of LwM2M. Yeah, of course. Just a quick overview of the different stacks that are used under LwM2M. It relies on CoAP, which can make the translation over every kind of transport that you could imagine, from LoRaWAN to very responsive connectivity over TCP, for instance. but the most common implementation is over UDP-DTLS. I talked about standardized data model, and this is what I was talking about. With LwM2M, you inherit from a data model that already exists, that you can pick and choose what you need in this data model. One part of the data model is describing the device, network connectivity, firmware update, etc. So it's more related to device management, let's say, purely device management. You can configure access control items. You can configure the APN you want to use, the bearer priority if you want, even the 5G bands that you want your device to use or to prioritize. So it can go very far in the device configuration, and it's already there, just have to use it. On the other hand, you have at the bottom of the screen, you can see just a few items from the, let's say, more business data that you may want to use. I just took 2 examples, but there is a bunch more, so don't hesitate to search and browse the data model, the LwM2M data model. This is an example of the temperature. So it comes from with a set of resources that you can use. You can see here in the middle that most of the items are optional. So it means that if you want to use it, you can, but you are not obliged to support every resources, which with already, so of course the sensor value, if you're measuring temperature, probably it's because you want to know the temperature, so the sensor value is the most important, and of course it's mandatory. But for the rest, it's up to you if you want to measure the min, the max, etc., the range of the sensor, what kind of temperature, for instance, you want to specify. So it's indoor or outdoor. You can put it in here in the application type. And it's the same type of data structures that you will have for every kind of data throughout the data model. So keep in mind that it's like a toolbox, and you will have the same, quite the same type of item in all the data model. You can see in this temperature example some standardized operation, once again, that you will find in all the data model, with the capability of reading the one data, writing, so for instance, configuring remotely a timer or whatever, and execute, which is basically how you trigger either a routine or an actuator in the read world, for instance. And again, you will find the same unitary operations throughout the whole data model. So it's really replicable. It's not because it's a standardized data model that it is a finished data model. You can expand this model with by integrating your own data, and that's what Adeunis did for their devices. And what they did is that, well, they reuse at the maximum what was standardized. So, for instance, you will Adeunis use a standard temperature, humidity, etc. data model. But for the items that were not present in the standardized data model, they create what we call the custom object, which is the same kind of structure, but with their own data they need to handle. So, for instance, CO2 level calibration, hysteresis, etc. So all that stuff is in a custom object, and unlike, let's say, decoders that are often a code that you have to write and that needs to be executed on the platform side. So you need to code your decoder in one specific language. In LwM2M, we are using XML files. So it's flat, it's standardized, it's understandable by every LwM2M server. So there is no question about compatibility again. even on custom objects. So what you need is only to write your own custom object based on the standardization, which is honestly, it's yeah, I have put an example here. It's quite self-explanatory, and you're good to go. And once you did it, you can manipulate your own data through LwM2M. So it's very, very powerful. Coming back to, let's say, telemetry, but I talk about data, but it can be everything. It can be business data, so for instance, temperature, barometric pressure, whatever, but it can also be items from device management. So for instance, if you want to remotely monitor at what stage of the firmware update you are, you can use it. So it's once again, when I talk about, let's say, capability of LwM2M, it's the same thing on business data or device management items. So you can remotely subscribe to one specific data. You choose remotely what data you want to observe, you want to get, etc. So you defined how the verbosity of your device remotely, instead of having it hard-coded in your firmware. You can set the transmission frequency. For instance, if you want data only if it changes, or if you want your data at least once a day, etc., you can put define the frequency you want to work at. You can add additional triggering criteria. For instance, if you only want to get the data if the temperature goes beyond 0 degree for freezing detection, for instance. If you are measuring, if you are monitoring a meter only for a certain number of steps of impulsions, of pulse, sorry. So you can further reduce the level of transmission between the device and the platform. And of course, this is fully remotable, so remote manageable. So you can modify over the time. If you don't need certain data, you can dismiss corresponding subscription, etc. So it's really up to you, and you can really adjust and optimize the data consumption and ultimately electrical consumption of your devices. One very powerful feature also on LwM2M is the bootstrap. It's a way to automate the provisioning and the security deployment of your devices. For instance, if you take one device out of the factory, you power on the device, and the device will automatically contact the bootstrap server. The bootstrap server will tell the device which security to use on the next phase, on the exploitation phase, the run phase, sorry. Which platform to use, which secrets to use for the connection, and which configuration use. Based on that, the device can now contact the run platform and authenticate with the given key and start working normally. Nobody has seen the secret because it has been generated on the fly, transmitted over the air, so nobody can make mistake, nobody can steal the secret. And ultimately, when you are in run phase, you can ask the device to visit again the bootstrap server in order to renew the security elements. So it enables you to automate your deployment, keeping your configuration always up to date, and manage your security items over time if you need to, for instance, renew the security over your fleet. So it's very transparent, very powerful. I use it many times with, we do a lot of tests with Adeunis devices. Demo with Adeunis devices. So once in a while, I need to reconfigure the device into the let's say the basic configuration. All I need is to ask the device to come back to the Bootstrap server, and it's fresh again. So it's in like 1 minute. So it's keep in mind that you just need to power the device, and 1 minute later, it's provisioned and running on the platform. On the implementation step, so I'm preparing the field for Mackenzie. You have two ways of using LwM2M, because LwM2M was initially mostly supported by telcos. You like 99% of the time, you will have a LwM2M agent embedded into the cellular module. But because of the constraint of the cellular module, you probably will have a memory issue, meaning that you will have some limitation using this agent, and not only this agent. If you are using MQTT or stuff like this, you will have the same kind of limitation. And also, probably you will have one of the first version of LwM2M, which does not provide the ability to use the latest optimization of the protocol. Instead of that, on the right part, you can use a firmware stack, a LwM2M stack that you will embed in your own device firmware, which gives you more flexibility about the version of LwM2M you want to use, how many objects, how many, let's say, capability you will be able to handle through LwM2M, etc. So it is way more flexible, and also it gives you some kind of independence between with your cellular module vendors, for instance. But it's not because you are using LwM2M that you don't need to write a firmware anymore. You still have to manage your own routines, the memory, the data coming from the sensor, monitoring the battery, etc., and ultimately also manage the cellular module to open the communication, to open the connection to the network, etc. Stuff like this. You still need to do that. However, LwM2M will give you, will facilitate the integration of what the discussion with the LwM2M server, because it's already defined. You don't have to rethink the protocol. If you want to perform if you want to perform remote configuration, how to conceive the communication between the platform and the device, so that the device understands that you want to modify the frequency of the data transmission, for instance. It's already available in the LwM2M toolbox. You just need to use it. So it saves you a lot of time when conceiving a device. And that's where the Iowa SDK from Interoperability can really help you on that. Just to finish, a few items on which Orange can support. I already talked about LiveObject, which is our IoT platform. We do have a free trial plan, so don't hesitate to subscribe. What we did with Adeunis, because we work with them since a long time, we had them to analyze, let's say, low-level logs on the platform to achieve a better energy efficiency. What else I talked about reusing the security context, etc., and avoiding the full security on checks, etc. So we worked with Adeunis on that in order to be sure that the energy consumption were at the lowest level. And we have also a partnership with Interoperability, giving you access to a 3 months free license of Iowa for you to start with LwM2M in the best configuration, because Iowa is very intuitive to use from a development point of view, and it's really an asset that you need to have in your development. The second part is IoT journey, which is let's say the front gate of IoT at Orange, with a catalog of certified devices and cellular modules. And of course, we are still identifying LwM2M supporters, so maybe some of you will be part of, I hope. So don't hesitate to have a look at IoT Journey. And IoT Continuum, which is our IoT coaching program, both on hardware and software, meaning the firmware side, with a partnership with Sierra Wireless, Lacroix, and ST Microelectronics. You will find all the links in the presentation, so don't hesitate. Otherwise, I'm available on LinkedIn, and don't hesitate to ask your question in the Q&A if you have any. And now I'll leave the floor to Mackenzie for the Iowa presentation.
Thank you, Mark. All right, so again, this is Mackenzie, and I will jump into using Iowa as a fast track for your IoT development. So I know I've already given a brief introduction of IoTrop, but here are a few more details to help you to get to know us better. So our vision is to help massive IoT reach its full potential sooner. But what exactly is massive IoT? Typically, the term is used to describe hundreds of billions of things or IoT devices that are connected to the internet and collecting and transmitting small amounts of data to platforms such as Orange's Live Objects. We've been fortunate to work with a number of companies globally across a number of verticals who share our vision. And through this, we're proud to say that Iowa is inside over 2 million devices. So if you've been around IoT for any amount of time, you can quickly come to the conclusion that it's a complex subject and that it's equally as wide as it is deep. And because of this, I think it's necessary to describe our place in the ecosystem. So if we break down IoT into 4 pillars, our sweet spot is really with IoT device lifecycle management. And why do we find this area so important? It really goes back to massive IoT. So if you're managing IoT devices and sending, say, a firmware update to 10 devices and scheduling them individually, device management probably doesn't seem like a big deal. But what happens if that's 100 or 100,000? Scaling quickly becomes a hot topic, and this is why we insist on thinking about IoT device lifecycle management early in the process. If you think about it toward the end, it's unfortunately too late. So let's dive into device lifecycle management a bit more beyond firmware updates. Lifecycle management covers all of the operations you'll have to do from commissioning to decommissioning, such as touchless installation, data collection and transfer, end-to-end security, etc. This can be pretty straightforward when you have the luxury of a reliable network and no real data restrictions, but there are specific challenges to address if you're running devices on high latency or error-prone networks. The stack size, the battery life of devices, message size, etc. start to become very important. So as of now, the only device lifecycle management protocol that's really meeting the needs of devices in constrained environments, like Mark very well described, is LwM2M. So before the industry adopted it, IoTrop invested in the standard, which was developed by the OMA, or OMA SpecWorks. And so just to give a bit of history here, LwM2M was created by telecom operators in 2010 to manage the fleets of their cellular IoT modems. So this brought more than just the transport protocol, but a device management protocol associated with the library of objects, like Mark described very well, in order to give organizations a flexible set of lifecycle management features to develop IoT objects. And since 2020, LwM2M has moved from telecom to cities, utilities, logistics, and more. So as I mentioned previously, IoTerop has invested in the standard since the birth of LwM2M. And David Navarro, our CIO, wrote 20% of the current specifications. So as a company, we continue to invest in the future versions of LwM2M. And because of this, our customers and people that work with us can benefit from the latest technologies because we bring solutions ahead of the market. So all this knowledge that we have collectively as a company has been funneled into Iowa, a software development kit that enables you to build your own LwM2M client in just a few days. If it's built on a very logical framework that anyone who has coded in C will recognize. And with a very small footprint at 40 kilobytes of flash and 5 kilobytes of RAM, Iowa implements the entire LwM2M specification, allowing you to manage your device's lifecycle. It brings about a lot of optimization in terms of battery usage, as well as advanced security mechanisms to encrypt your data, authenticate your communication, and secure your links. Now let's dive into what Iowa lets you do. As you can see here in these two C code samples, you can implement a firmware update or push your data to the cloud using just a few lines of code. And thanks to its extensive documentation, numerous sample codes, and its straightforward application programming interface, you can build your device without knowing the intricacies of LwM2M or CoAP. Iowa can work on any chipset and on any operating device, or even without an operating device. The basic but complete hardware abstraction layer in front of you will let you implement Iowa even on bare metal. So IoTerop and Orange have partnered together to build a dedicated Iowa pre-configuration to onboard with Orange LwM2M Live Object Server in just 5 minutes. If you're interested, we can provide a 3-month evaluation contract where we can share the source code with you. So let's talk a bit more about our work and our customers. Here are a few companies that have used Iowa. And because our technology allows you to work on the most constrained devices, we address the needs of a large variety of industries. These industries range from metering to tracking and cover a large range of sensors, as well as network gateways. We cover a variety of communication types, ranging from satellite to cellular communications to wireless mesh. So I can tell you more about Iowa and its global applications, but it's really better when it comes from one of our customers. So here's an example from David Rowe of EDMI, who integrated Iowa into their WP20 NB-IoT smart water meter in just 3 months. This is a revolutionary meter because it works for up to 20 years in the field without having to be accessed. So let's take a moment to listen to what David has to say.
Market analysis, we looked at a lot of choices and a lot of vendors, pretty much everything on the market that could give us a LwM2M head start with a robust, mission-critical, production-ready solution. So the factors that came into consideration were speed to market. We didn't want to work with someone to help them develop the product. We wanted a finished product that would allow us to get our product to market. And we needed the maturity of the code, the documentation had to be ready and go. So we just read it and implement it. leading features. Of course, having version 1.1 on our product is awesome. Support in the early stages, before we came up to speed, we needed enormous support, basically phone call support on a daily basis. And then when you look at the cost benefit of buy it versus build it, that was a key part in the commercials, and the attractive pricing models that were offered. So when we combined all these together, there really was only one choice that was available and viable, and I don't have to tell you who that is. I think you have a pretty good guess. So we're very happy with the current company.
So first of all, very, very strong.
Oops. Okay, there we go. So we'll move to the next example, which we have on this slide. And this is with Z. McLean from American Innovations. And they worked to develop an oil and gas pipeline corrosion monitor. And impressively, they were able to launch their product in 2 months. So let's give a quick listen to what he has to say as well.
Now, the advantage for using the Iowa lightweight M2M client was definitely one of the big ones was time to market. It took us about 2 months for our firmware team to start to upgrade to Iowa because we wanted to take advantage of the lightweight M2M 1.1 and 1.2 specifications. Iowa is light and easy to integrate. It has a small code base. The impact to our binary was negligible. I also want to mention here that we had really good support from IOROP during our integration phase, which also helped us accelerate the integration. And also, the one big advantage of using Iowa is its small memory footprint. So when you have small battery-operated IoT devices, you don't have a lot of memory on those devices. So Iowa helped us save some of that memory so they can be used for other processes.
So to summarize, when you're facing an IoT project and you want to go fast, Interoperability can help you to jump into device management without jumping into the complexities of it. We offer out-of-the-box solutions to focus on the user experience and the technicalities of your project. And the best part is that you can do it quickly, and we guarantee a proof of concept in just 5 minutes.